Yeah, so so this will be the agenda. So we'll be talking about prerequisite knowledge and then R application, machine learning. So the R application and machine learning is the prerequisite knowledge. And then we talk about the machine learning with R. So hopefully R Studio is okay when we reach the machine learning with R. Okay, introduction. We are GLC, Gadalitas Chakrawala. We're based in Bandung. Our areas are training in IT consulting. We're doing MikroTik, uh, Ubiquiti, and Linux administration. We also do our own product that is Radius Manager, and then we do a regular event. My name is Achmad Mardiansyah, and then based in Bandung. I'm Linux user, MikroTik user, networking user, also doing programming. I haven't updated the stuff here. So what I'm doing, so I'm trainer, I'm teaching, I'm doing consulting, and then we are doing programming as well. Yeah, I need to update this slide here. Yeah, okay, so I have several websites and then also LinkedIn. So guys, if you have a LinkedIn account, and then I would like to connect with you. And in the past experience, we do network support together with the system administration, and then do some programming to do integration with other stuff. And then for the GLC webinar itself, we do every Thursday evening. Language is English. Okay, for those who are wondering um, what is the language of we are using during the webinar. Yeah, so default is English, except if everyone here is Indonesian, and then I will speak in Indonesia. Okay, so guys, please come early, because if you are late and then everyone here is in Indonesia, and then I'll be speaking in Indonesia. All right, so yeah, that was the GLC webinar, and then from yourself, please introduce yourself. Okay, say where you are from, and then your background related to the topics today. Okay, please. Okay, please say where you are from. Are you from Indonesia? In the chat box. Okay, I can see one here from Laos. Okay, thank you. Others are Indonesians, I suggest. Yes. Okay. Okay, let's continue then. So can you hear my voice, and then I see the slides clearly? Hello. Hello. Can you see my slides clearly?
Yes.
Yeah. Okay. Thank you. Thank you.
Clearly.
All right. So prerequisite. We assume you already know the R applications. Okay. And then the machine learning. Oh my God. Come on, R Studio, come up. Sorry. Yeah, so let's review. So let's talk about machine learning versus data science. So here they are. So basically this is from the, I forgot the name, from Conway, yeah. So from Drew Conway. So this is coming from Drew Conway. So actually, so he has an idea about how to map between machine learning here and then the data science. Okay, so the data science actually is it's a group of knowledge, which consists of computer science, math and statistic, and then business and domain expertise. So when we talk about the data science, it's not only for computer science because this is where we are. So mostly we are, if you are from informatics or computer science, this is where we are. So we are doing software, we are doing algorithm, we do programming and all computing stuff. It's here. And then when we combine that skills with statistic and math, and then we can learn the machine learning. Okay, uh, but uh, but we need to know that. Okay, after okay, we already know the machine learning how it works. Okay, but to analyze the data, we need we need the help from the expertise. For example, we want to analyze financial data. For example, the credit analysis of a bank. So we need somebody from bank that tells us, okay, if you see this spreadsheet, and then uh, this will be the account that you need to look for. Okay, so you need to see these parameters instead of that parameters. Okay, so that's the business domain expertise. Okay, so that's what happened when we talk about the machine learning or data science. Okay, so yeah, we usually this is us because my background is engineering, so I'm more on this and this. Okay, uh, I had a course with the programming and also statistic in my college. Okay, so that was the at least we got an idea about the difference between machine learning and data science. Yeah, so this is the data up to the intelligence. Um, yeah, so this is operational data, and then we do a collections through our sensors and everything, and then it will come the data put into the database or any other storage a place, and then we do processing, and then we get the information, and then we do the analysis and production, and then it will become the intelligence. So where the machine learning do the role, so it's in here. Okay, uh, yeah, so yeah, we can learn something from the data to get something from the data. So we the ML, the machine learning or data science plays an important role here to get the intelligence from the data. Okay, of course with some techniques that will be discussed later in the slides. Okay, so again, so we already have data, and then the data will be analyzed to get insight from them. Okay, so yeah, this is the business value versus complexity. First is if we just do the reporting like a dashboard, that one has a low business value. And if the data is of more process, and then it can explain why, and then it's called detective analysis. Okay, if it just inform what's happening now, it's called dashboard, and then what's likely to happen, and then it's called predictive analysis. Yeah, so the more we go here, the higher business value. So if for you guys, if you are doing a software, um, and then if you want to actually why we use software, because we want to do automation, right? Automation maybe can be done here, but if you after the automation, and then what? We expect that with our our software can predict something, right? So yeah, with that we can improve our software so that it can predict something. Okay, so that on this level, we can include the technique from data science or machine learning. Okay, I do. Yes, I do. I do. We do make software. Yeah, we do create billing. Okay, but if we just do billing and then other stuff, and then what's the difference between our software than other software? Okay, so with our software, we want to increase the capability so that it can do something with the predictive analytics. Okay, so while if we are pushing forward, and then we can use big data. If this one is in the phase where the data is very big, so the software that you'll be using here will be not traditional software, but you will use software that is able to manage a very big data. For example, hard disk, the biggest hard disk now, I don't know, in the market is 20 terabytes, right? 20 terabyte hard disk is the single hard disk, the biggest capacity of single hard disk at the moment. So I already find in the Amazon, in the online shops, the biggest capacity of a single hard disk that I can find is 20 terabytes. But but the data that we have is more than 20 bytes. How can you put the data? For example, we have 1,000 or 3,000 terabytes. Okay, you have 3,000 terabytes data, and then you want to put storage. So that's why you need to have a system that is allow you to put storage, to put your data with the 3,000 terabyte capacity uh, in your system. So that system is called big data. Uh, for example, this one is like example implementation is like Hadoop. So Hadoop is an ecosystem, consists of um, several software where it can store a huge amount of data. Okay, so that was about the data analysis level. So when we can see here, the present is the result from the past. Okay, and the past is the key for the future. So this is our timeline, right? Okay, so this is where we are. This is present, and this is future. This is past. Okay, so the present is the result from the past, and the past is the a key for the future. What's that mean? Because here we are collecting data, okay, from collecting data from the past. So we always collect data from the past, right? We never collect data from the future, right? So that's why, uh, based on the past data here, we can predict something in the future. How come? Because um, what happened in the world here usually is a cycle. Okay, it's a cycle like this. Sometimes you go A, sometimes B, and then C, and then D. Okay, just a cycle. Okay, if we know the pattern from the data, and then we can predict the future. Okay, so we never know what happened in the future, but we can predict the future based on the past data. Okay, understand up to this point, right? Yeah, okay, so I like this quote. The present is the result from the past, and the past is the key for the future. Okay. Uh, yeah, I think also there is a quote from the Kung Fu Panda. Future is mystery. Yesterday was history, and that's why today is called present. Yeah, it's a good quote actually. Okay, let's talk about the R and RStudio and RStudio Server. Yes, so sorry guys, I'm still struggling with the RStudio here. RStudio Server, I mean. So, because that's the only software we have. So R means, R is a software. It's a free, it's open source. Uh, it's unfortunately it's a command line interface. Unfortunately, yeah, it's a language. Okay, so it means that it's a programmable. Okay, programmable, so that you can do if this and then here. It can do like data structures like array, right? So if you are a programmer, you must know array concept, right? In PHP or in Java or C, and then it's called array, right? But in Python you call it list. Okay, but the concept is similar. That where the variables, okay, and then you have index, okay, for mentioning the data. So an array consists of A, B, C, D, E, and etc. etc. Yeah. So this is how it looks like. Okay. That's for example, that's an array. Yes. Same concept also um, available in R. Uh, but the main purpose for R is for statistical analysis. So R in the beginning is designed for doing statistic analysis. You're doing a mean, a median, modes, yeah, um, yeah, like a probability and so on and so forth. So R is an example of yeah, example of statistical software. Yeah. So it means that I need to understand the R programming. Yeah, yeah. There are some commands in R where you can do the the stuff, analytical stuff related to statistical. But uh, in the beginning it was for statistic. Okay, but because R is famous, lots of people are using it, and then lots of people also contribute the modules. Okay, so that's why R is not for statistical, but also for further analysis, including the data science and the machine learning. Okay, so and this is the R Studio. Okay, R Studio is the graphical user interface of R because okay, because you don't want to work only with the command line, right? So you need to have something. For example, when you do analysis, for example, data visualizations, so probably and most likely you need to have a software that can give you a graph right away, right? And then that's the that's where RStudio come. So RStudio is a graphical interface for R. It's a free. This is the software that most likely you are using during your assignment related to a data science or statistical or anything related to that, including machine learning. It's standalone, so you just install it. There is a version for Mac, for Windows, for Linux. Okay, you don't have to a version. You don't have to worry about that. It has also professional version. Okay, which includes more features compared to a community edition. Okay, so that was the R Studio. Next that I want to talk about is the R Studio server. So it's similar to R Studio. Okay, So it's a server version of RStudio. Yeah, it's also free. And the way you use this is what we use in our organization. Okay, so we just install RStudio server in a server. The server is in data center, and then we just do VPN to connect to the RStudio server. It's good for for doing the analytics. Okay, so that we don't have to install the R uh, in our own laptop. Okay, so the way we use is we use the web interface that is provided by RStudio. Okay, so it's the look and feel is similar to RStudio standalone. Okay, this is what we like. RStudio server is very good if you are doing centralized processing, and then uh, you can work from anywhere. And then it also has a very good session management. Okay, for example, this is the server. Okay, RStudio server. Okay, and this is your LAN, right? Connect to this, and then you can work from anywhere from the cloud, right? From here, from there. This is your client. This is a client. This is client. Okay, client. This is cloud. Okay, cloud. Yeah. So this is how you work. You work through to to a laptop here. You don't have to install anything on your laptop. Only just a web browser. You open the RStudio server. Okay, and then yeah, that's it. If you are leave, and then the session is still available in the server, and then the program is still running. And then you will not lose your own session. Okay, so that's very cool. So it's similar to when you are doing a remote desktop or a team viewer, right? Right. Yeah, it's similar to that. Okay, so if you are doing in the middle of something, doing the analytics, which takes hours to process, and then I think RStudio is a good choice for you. Okay, so that was the RStudio. Uh, okay, let's talk about the machine learning. Okay, as I said in the beginning, um, so this is where we are. The machine learning. It's a combination of skills between computer science. So here you are doing programming stuff, and then statistics here, where lots of statistical theory is applied to get insight from the data. Okay, so it's a combination between computer science and math and statistics. Of course, there will be a data. Uh, so the data must be exist here, and then with the machine learning, the data will have an insight what you want to do with that. Okay, so this is the machine learning as I informed you before. Um, so the purpose for machine learning is to get insight from the data. The method can be supervised or unsupervised learning. This is just an algorithm how to achieve machine learning. And then actually after this, there is yeah, better if I talk about the issue here. Yeah, uh, yeah, it looks like a little bit scary. Um, yeah, actually there are five. So previously, okay, let's talk to the previous slide. So, okay. So, does machine learning can solve all problems? Answer is no. Okay, not all, uh, not all case can be solved by machine learning. Okay, so what are the problems that can be solved by machine learning? So here it is. Uh, okay, let's use orange. Yeah. So first problem that can be solved by machine learning is estimation. Maybe in green. Yeah. So how to estimate? Okay, so here you can use linear regressions, neural network, uh, support the vector machine, SVM, deep learning, etc., etc. So we are trying to estimate the future number. Okay, so for example, this is our data, day 1, day 2, day 3, day, you mean day, yeah? Or date, or day number 3, day number 4, for example, the uh, the um, so the graph will be like this: 1, 2, 3, and then what will be the D5? Okay, so this is D2, this is D1, this is D3, this is D4. Okay, what will be on D5? So we estimate what will be on D5. Okay, based on the trends here, for example. So most likely it's going to be here, for example, right? Because there is a pattern. So it's we estimate the trends. If you are learning linear regressions, that's what happened. Linear regression is one model, yeah. So where we predict y, okay, from the a x plus b, right? So this is x value, and then this is the predicted number. So it's gonna be like this, right? So this is x, and then this is y. So and then this is your line. Okay, okay. The formula here will determine the lines over here. Okay, and then these are your data. Okay, so is your data has a trend or not? Yeah. Usually we talk about the dependent and then um, independent and then dependent variables. So this is independent. This is dependent. Okay. Why? Because it depends on the x value. So the y is depends on the x value. And then here we can apply correlation or covariance. If the correlation is positive, close to 1, and then the data uh, will have a good what is it? Good correlation. Okay, so data has a very tight between one and another. Is it causality? Not always. Yeah, but they have a very good correlation. Okay, so that's what happened when we use linear regression. Also, we can do prediction or forecasting. Yeah, so this we can do linear regression, uh, neural network, support vector machine, and then so on and so forth. So the bad things about linear regression is can we apply linear regression for all case? No, it's not. Why? Because it's linear. That's the problem. what happens when we have a data that has cycles like this? Okay, linear regression will think, oh, okay, so it's going to be like this. Well, yeah, that's linear regression, but our past data doesn't look like this, right? So we can use other methods like uh, neural network or others, a method for achieving that. Okay, so that's the first, and then the second case that can be solved, not can be solved, can be yeah, I can say it can be solved by machine learning. Okay, the third problem is classification. Oh, what's that mean? Uh, this is very good for classification. Is very very famous for CV. Okay, what is CV? CV means computer vision. It's like the one that is built by Tesla. Okay, with the one that is using the camera. Okay, so for example, um, you have pictures, right? This is a picture of A. This is a pictures of A. This is a pictures of uh, A, for example, and this is the pictures of B, right? So if I give you this picture to human, you will know that, okay, this is letter A and this is letter B. Okay, so it means that you already have a classification in your mind that, oh, this picture is classified as A, this picture is classified as B. Okay, because you already train your head, not head, your brain, that, okay, you already recognize the pattern that, oh, this is A, this is A, this is A. Even though you are, for example, uh, this is a little bit tilt, okay, or maybe we can do an extreme uh, examples like this, right? So yeah, you have in your mind that this is A. Okay, so that's example of classification. Okay, so it means that you have an ability to classify a data. Okay, so we have data here, data number 1, data number 2, data number 3, data number 4, data number 5. And then if I give you this data, and then you can classify data number 1, 2, 3, and 4 are in the same classification. Okay, and data number 5 here is not belong to data number 1, 2, 3, or 4. It's a separate group. Okay, so classifications is known as grouping. Okay, right. So based on that, information, we can do yeah. To do classification, we can do decision tree. I mean the algorithm. We can use a Naive Bayes. This is very very common if you use a spam filter, right? So you are classifying, right? Spam. Okay, this is the first classification, and then not spam. Okay, next is K nearest neighbor, LDA, logistic regression. Look, again, it's a regression, but this is logistic regression, not a linear regression, so it's different. Okay, so that's the second. That's the second problem. where can be solved by machine learning, the classification. Okay, so again, first is estimation, second prediction, third is classification. So it means that, okay, if you have a car, okay, it has two wheels, right? Okay, yeah, it's not very good car. And then you see a stop sign here, right? Okay, so the machine on the car here will see, oh, okay, there is stop sign. I will recognize the stop sign and then I will stop the car. So that's one example of implementation of classification. Okay, so we need to uh, identify the data. Okay, so that's the classification. Next is clustering. Right. So clustering means it has ability for um, to grouping the data. So it's similar to classification. Okay, so it's similar to classification, but yeah, it has an intelligence for uh, yeah, it has intelligence for grouping the data. Okay, so for example, you give them a pictures like picture A, picture B, picture C. This is another A with different shapes, right? Yeah, but with the clustering, you give them to the machine learning algorithm, yeah, and then it will check, oh, okay, data number one, this is number two, number three, and number four here. Well, okay, so with our algorithm, we can say that the data has three groups. Okay, okay, what are similarities between them? So yeah, first is group A, and then group B, and then group C. Well, in the data, we never know what kind of classification. We never inform the machine learning that actually there are four groups or three groups or what kind of groups. We never inform the machine learning. Okay, but the machine learning, if we give them the data, okay, here is the data. Okay, data number one, data number two, three, and four. Okay, please group it. And then the machine learning is able to group. Oh, okay. So actually, based on the data you give, I will classify them into three groups like this. Why? Because group A has a similar features like this, for example, right? B is this and C is this. C is not similar to B. So I will say C, data number four, which is C here, is belong to different groups. Okay. So that's the clustering. Next is association. Okay, this is so this two is very common on CV, computer vision. Okay, the one with the cameras, or the one with the image recognition, same thing. Okay, classification. Uh, Also the decision, like decision tree here, to analyze whether for example, you are a part of the data that um, has a similar feature or not. Okay, so for example, in the case of academic information system. Uh, academic, okay, academic information system. So here you put the GPA, right? Uh, you give data for is it male or female? Okay, is it from a GPA of semester 1, semester 2, semester 3? Okay, and then here you give a prediction of is it a graduate on time? Okay, so here's the punchline: graduate on time or not on time. Okay, so this is the data. Okay, and then the purpose is to predict whether this a particular student graduate on time or not on time based on the previous data. Okay, so that's the one example of classification and clustering. Okay, associations is used, for example, uh, in the online shop. Okay, in the online shop. So, for example, if you want to buy this, you want to buy product A, okay, and then there will be a recommendation, right, on the bottom. Okay, recommendations, for example, product B or C or E, for example. Yeah, so that's example of association. Why does the Amazon knows? Because it is from the past data, and data in the past usually people buy if people buy A, usually they also buy B, product B. Also, they people from that buy product C also buy product B, right? People that buy product C also buys product A. Okay, so that kind of relationship is recorded in the past, so that based on that information, we can come up with a recommendation that, okay, if you buy A, well, people also buy this stuff. Well, sometimes it works, sometimes not. Okay, so yeah, so those are 5 cases where it can be solved by machine learning. Any questions so far? No? Looks everyone is good here. Okay, guys, hopefully the server is okay now. Everyone can see my desktop? No?
Yes, sir.
Okay, so here it is. This is my server. I access it through my VPN. So yeah, let's try to get in. Yeah. So yeah, hopefully it can pass username studio. Password is password. Yes, 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 yes. Oh, I don't know what's going on here. Let me try. Or lock our studio server lock. Okay, not exists. What's happening? Oh. Looks like it's not working. Hmm. Okay, perhaps I can show you my R Studio because all the materials are here. Okay, the things that I want to show you is here. But really sorry for that. I got problem with the R Studio server. Okay, but the one that I have now is the R Studio, the standalone one. So this is how it looks like. Okay. So okay, before I go, how many of you already use R Studio before? Hello, anyone? Or this is your first time heard about the R Studio? Hello, hello.
Yes, that is my first time, sir.
Okay. So let's talk about the R Studio, okay? Because yeah, I was thinking, oh, I'm talking about machine learning, but most of the audience they just know R Studio for the first time. so so perhaps we can talk about the R Studio now, instead of talking about machine learning. Okay, so R Studio, this is R Studio looks like. Okay, this is the standalone version, not from the server version. So this is where you type your own program, and this is your this is your environment. You can see here the variables, history, connection will be here, and then this is the console. Okay, the R console. Okay, so if you are using R, actually you are using this. And then this is the plots. Okay, if you have a plot, you want to set up a graph, and then this is the place. Okay, so yeah, as simple as that. So let's say I have, we can say I want to load a library ggplot. Okay, either you can use here or you can use here. So in just is similar. This is like IDE, you know. So if you put library, and then there is a linter. Linter means, see, this is linter. Okay, so it will give you a help. Okay, what kind of a word that or a keyword that you want to use here. Here's the several options that you can use here, and then here, and you can use one library, famous library for also has a linter ggplot2. Yeah, okay, so you can write your own program here and then click run. See, so same thing. So if you type here, and then it will be executed at the bottom. Okay, so as I said, R actually is just a command line, but with R Studio, you can have a cool feature with that. Okay, so let's display diamonds. So I have a data set here for the diamonds, and then this is how it looks like. Okay. Okay, so yeah, here's the, actually it's a data frame. We call it data frame. Data frame is it's a table. Actually, it's a table that consists of data. The data has 53,940 rows and then 10 variables. So you can see this data is like a normal table. Okay, so data of the diamonds. So here's the diamonds. Okay, and then they have 10 variables. Okay, so this is variable number 1, 2, 3, 4, 5. The variables are price, carat, cut, color, and so on and so forth, right? And then about the rows is like this. Okay, so there are 53,000. Okay, so this is how it looks like. Yeah. Okay, so we also can, because I already have the diamonds, and then I can load the diamonds. So this is how it looks like. Okay. So 1, 2, 3, 4, 5. So this is the data. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 variables. Okay. And then the total entry, total record is 53,000. Okay. Others, we can use data from Iris dataset. This is very famous. Okay. Which is showing you the total number of uh, sorry, Iris is one data set that is used by many data scientists over the world. It is from it's taken from the what is it? Yeah, here. It's taken from the observation, and then the data is used for many machine learning algorithm. Okay. So basically, iris is a set of data where it defines, as I said in the previous one, is the classification. Okay, one example of classification, classification of a flower. Okay, the first variation is setosa, and then versicolor, and then virginica. Okay. Yeah, we can do also plot here. Yeah. So, but this is the command where we plot the data, iris, sepal width, and sepal length. Okay, as you can see, this is the X and this is the Y. Okay, Y here, X is this one. Okay. Yeah, this is how we plot with the command plot. Okay. We can also use other data like MPG. Oh, looks like it hangs. Oh yeah, no, it's not. MPG, for example, this is another data. Okay, MPG means miles per gallon. So like kilometer per liter. So you have if you have a car, okay. So this is America. You have miles per gallon, okay, or MPG, okay, or kilometer per liter. So 1 liter, how many kilometer it can go? Yeah. So here you can see we have data from MPG. Sorry, we have data from several manufacturers here. Okay. Yeah. So it says that this is record. This is the record. Here's the record. Okay, and then here is the variables. Okay, model, display, year, cylinder, transmission. Is it automatic or manual? Drive, is it forward drive or four-wheel drive? Okay, and CTY, city, city, and then highway. Yeah. So if it is in the city, okay, if the drive in the city, and then it's 18 miles per gallon, and then if they are running in the highway, it's more efficient because, for example, the record here is 29 miles per gallon. Okay, so this is what we can see. Okay, so yeah, that's example of the data, and then we can do a quick plot, for example. Okay, so here we can display. So here we can display the highway. And then the data. Yeah, this is the display. So this will be the x-axis. Okay, and then highway will be the y-axis. Okay. So display here means displacement. Displacements. Let me check the technical term. Displacement in car. Yeah, here engine displacement. Okay. Yeah, so it means like measure of cylinder volume swept by all the pistons. Okay. Yeah, so as you can see, displacement here. Yeah, displacement. It means that yeah, yeah, the volume where the combustions is done is happening. Yeah. So this is engine displacement. So the displacement of the, I think displacement of the piston here. Okay, so yeah. So again, as I said, okay. So when we do analyze a data, I'm from computer science. I know statistics, yes, but when we talk about computer science, yeah, there are other also stuff here. Which is belong to business or domain expertise, which means from the person that knows well the car engine. Because yeah, I mean, to be honest, I don't understand the displacement. Okay, so that's why we need somebody from the domain expertise to explain us what is the displacement. Okay, so yeah, that is what happens. So when we have a data science or machine learning project, we are not alone. We as a programmer usually is accompanied by the person who understand the 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 domain. Okay, so this is how it looks like. Okay, we can do the plot, and then actually we can see there is a trend here. Okay, there is a trend here is going down, right? So if you want to have a higher, this is a higher efficiency, right? So it's like, for example, this is 40. So 40 miles per gallon. And here, for example, this is very, very bad. Perhaps 3 miles per gallon. Okay. So it's very, very, very thirsty. The engine is very thirsty. So as you can see, we can see that when the displacement is low, we can see the trends that the engine is much more fuel friendly. It doesn't consume much fuel compared to the engine that has higher displacement. Okay, so I think it's quite hard. Hopefully you can bear with me about the topic tonight. Oh, it's already 8:45. I think it's time us for say goodbye for tonight's topic. Okay, so it's time for video. I will stop sharing. So if you don't mind, please again, please open your not microphone, the cameras. Okay, so we'll take a picture for all of you here. So guys, again, yeah, please open your camera. I will take a picture. Okay, 1, 2, and 3. Okay, thumbs up. 1, 2, and 3. Great. We have 17 percent here. Never mind. Okay, guys, do you have any questions? If you have questions, and then you can type something in the group chat. Sorry, I think if we talk about the machine learning, I think it's too far, because I can see most of you are just first time um, hearing about the R Studio. All right. Perhaps next time, I think we can discuss more further about the machine learning or data science. As usual, feedback is available here, and yeah, see you again in the future. Okay, thank you very much, and then have a good day.
All right.
Okay,
Thank
thank
you.
you.